So week 15, you guys are getting into scatter plots and correlation and regression. And the first thing is to really look at a scatter plot to see visually what is happening, and then basically find the values that kind of correspond to what you're seeing visually. Now, you don't necessarily have to create the scatter plot unless you're asked to. I like to do it whether I'm asked or not, just to see the visualization because it helps. So, but we're going to create a scatter plot here, and then we'll see if we have an outlier or not, and look at the pattern. So this is the information that we have. We want to, okay. A pediatric nurse marks down the ages and heights of all female patients that she sees in a day. Create a scatter plot of the given data. So we want to determine which situation, which variable would be my independent variable, and which would represent my dependent variable. An age, I think, would be my independent variable, right? And height would be my dependent variable because it makes sense that height would depend on age. So we'll call age our x's. Oops, our x's. And height would be our y's when we're talking about like a linear type of situation. And then we have L1 and L2. So I'm going to put my dependent stuff, my x's in L1, and I'll put my y's, my independent stuff, my x's in L1, and my dependent stuff, my y's in L2. And so in order to input data into our calculator, hopefully we remember. Okay, so we're going to stat and then edit. This is the same thing that we've done before. And then we're going to input our x values in L1. If you have anything in there, you scroll up to L1 and press clear enter. That would clear out your list if you had values there. I don't, so I'm just going to start putting my age list into my L1. So you do it with me: 3, 5, 4, 8, 6, 10, 3, 7, 9, 9, 5, and 10. I'm going to put so L1, you see it's at 13. That means I had 12 values that I input, which is a good little quick check. My L2 is going to have my heights, my 90, my 102, my 94, my 118, my 105, my 125, my 87, my 115, my 134, my 121, 104, and 128. And, as you get to the bottom here, you should basically have the same amount of values in your X as you do your Y. Okay, in your L1 as you do your L2. So they both have, 12 values, which you can always verify and make sure that you have 12 values here. So if I'm counting, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 in my X and 12 in my Y, which matches what I have here, which, at the end it says L2 13. They both had 13. I'm on the 13th value, which I didn't put any numbers here. So there's 12 above it. So that's like a quick check just to make sure that, that I input everything correctly. And then let's go ahead and find the scatter plot. So we go to second, quit to get to our home screen because I like a clear screen. Stat plot, second, y equals. I want number 1, turn my plot on. So go to on and highlight it, make sure that it's highlighted. You see all these graphs here. We want the scatter plot graph. We want that highlighted with the dots. X list is in L1. Y list is L2. You can mark it different ways. We could put a dot, we could put a square. That's just how, the graph would look. If I go to graph, nothing pops up. Now that's not a coincidence. My window, I have to check my window. And in my window, I see that my X min was -10. I want my X min to be 0 and my Y min to be 12. And the reason, my X min to be 0, my X max to be 12. And the reason that I picked those numbers is because you see on my X list here, my smallest number is 3 and my largest number is 10. And I need my X min and X max to like be a little bit outside of that, because it has to show the values that are in the list. So when it was at -10 to +10, it was kind of like a little too far. I want to be more focused in what this says. And then if I look at my Y list, which is my heights, my minimum is, looks like 87 is the smallest value, and the highest value looks like 134. So I'm going to pick numbers for my Y min and Y max based on that. So I picked 80 for my Y min, and my Y max I might pick 140. And this is just values that are a little bit outside of what is shown in the set. So just to watch what happens when I go to my graph, just to have my graph show up. When I go to graph, now I see my scatter plot. So this is what my scatter plot looks like. You could see a nice linear trend. And the reason I say linear is because the points are very close together. And they're kind of moving in a line type of fashion, a linear type of fashion. And so that means it's going up in a positive linear way. So what type of pattern does the graph show? For me, it looks like it's linear, right? It's a linear pattern. And I would say that it's strong because I can determine the strength. And actually, I can determine the strength based on how close together the values are. Let me erase this. So let me erase this real quick. Okay, so the reason I wanted to erase that, because I need to say not only how strong or weak the correlation is, but I want to determine or also talk about whether it's positive or negative. And being that it's the values or the points seem very close together, I would say it's strong. The closer the points are, the stronger the correlation. And I would call it linear because they move up in a linear type, a line type of pattern. And I would say that it's positive because it's a positive, it's increasing from left to right as X increases, Y increases. So I would call this a strong positive linear correlation. Strong positive linear correlation. And then the other thing that, and we could verify this also based on your hypothesis testing that you get into, based on your correlation coefficient that you'll get into. All that is going to basically follow suit with what you're seeing visually. That's why it's nice to see the visualization, because the values that you calculate later are going to help verify what you see visually. Identify any outliers. Now, technically, in order to identify outliers, there are other things that we would have to do to verify outliers. But if I want to look at this visually and determine if there is an outlier, you know, you can look and see like this point here, up here, it looks like it's kind of far away from the general scheme of things here. It looks like it's further away. If I were to draw a line kind of in the middle of these values, you can kind of see that that would be further away from all the other points. So this one we'll call it's a possible outlier. We're going to say that it is an outlier just by looking at the situation, but it would be important to verify that with tests and different calculations. But you're not doing that in this particular course. So you're just kind of looking at it visually to say if it's an outlier or not. And you can kind of determine, let's say that it is, because it looks like if I were to draw a line here, which you'll learn how to draw that line of best fit in some of the other videos for this week. You'll be able to draw the line of best fit here and determine that that's a little bit further away from the line than the other points are, and therefore we would call it an outlier. But again, like I said, we want to verify that with other tests, but you don't have to do that for this course. So visually, you know, you're just kind of determining whether you have an outlier or not. So in this particular case, we'll say that that one is. One more thing that I want you to see is if you click trace here next to graph, just click trace and press, kind of right or left, you're going to see this little, like, we used to call it like a spider looking thing. We used to see this thing moving across, right? And it's not going to every single point, but it's going to the points that probably are going to be used to kind of determine the line of best fit, a possible line of best fit. And sometimes there's different lines of best fit, quote unquote. But you could determine, going back and forth, you can kind of look and see that that one point is kind of further away from that general idea. Again, if you trace your values.